Now, our next speaker is probably the one you've all come for, and that's me. So how's that? Mr. AD person? He just raised his thumb. So it must be on. Let's see what happens here. Excellent. So who's got the microphone? I'm J.C. Schaffler. I'm currently employed with the Intel Open Source Technology Center. I'm the Linux kernel maintainer and original author of the SMAC Linux security module. I was the technical editor for the POSIX P1003 1E2C working group. Just for a show of hands, how many people here does that mean anything? Okay, I knew I was going to get at least one. Okay, this is the Unix standard for security interfaces that actually grew into the bulk of the Linux interfaces that we have today. I worked for a long time with Silicon Graphics, where we did the first implementation of most of these things. And we actually suggested the very first version of the Linux security modules infrastructure, which was brutally and unceremoniously dispatched the way much open source software, but I'm not bitter. So what am I going to talk about today? I have a lot of things to talk about, but I'm mostly going to talk about security models, and I'm going to talk about how security models are interacting today, how things are arising, and how it is that they're running among. I have this up not because it has a lot to do with math models, but because it's one of my favorite pictures of all time. So we're changing our models in computer security. We're changing them rapidly, we're changing them dramatically, we're changing them in ways that nobody has anticipated and nobody is really looking for. And so, as security professionals, I don't know how many of you consider yourself security professionals? How many of you consider yourself security amateurs? How many of you don't care about security because you thought that the tone of the meeting here was just right for you? Okay, sorry. So we have distribution models, and the old distribution models were what we call distros. We had Red Hat, SUSE, Ubuntu, Debian, Slackware, a whole bunch of others that we don't hear much about anymore. They're out. They're old hat. Nobody cares about them anymore. What we care about now are operating systems. Android, Kaizen, that one name used to, because that's what I'm Chrome OS. These are what they are actually is specific installations of what we used to call software distribution. We're calling them operating systems now. They're targeted, they're focused, they have a specific purpose. Our installation models are changing dramatically as well. We used to talk about what happened with how do you get your system installed. Well, it's just admin sat down with it, and a few days later, and many years later, your system would be installed. Now, we're talking about the user experience of installing applications on your device. A very, very different model. A much friendlier one, but again, a much more targeted one. The responsibility model is changed so radically you can hardly consider it in the same kind of context. Because we used to say that if you did something on the system, it was your fault. Now we say, oh, hey, the application got hacked and now we blew everything away, sorry, it's the application's fault. So identity is changing. It's no longer, we're no longer talking about responsibility for what you do on the computer. It's responsibility for what the application does on the computer. And that's really scary when you get asked, hey, can this application talk to the phone book? Oh, sure. It's not my fault. It's the application. And privilege models. Now, the pictures here aren't really good pictures here. This is the slide I added at the last minute. It used to be the application got given a set of privileges. It was responsible for dropping privileges it didn't need, picking them up when it needed them. As Russell mentioned earlier today, it's responsible for opening things with read-only access instead of read-write. All it's ever going to do is read the file. And now we say that we're going to pass the privilege mechanism on to the API. I have an application that goes and does something. It's like, well, the API had privilege to do that, so I can do it. For Unix programmers, the whole notion of an API having privilege seems quite bizarre. Whereas for Windows programmers, that's the only way you grant or relinquish privileges, by using an API that is allowed to do things. How many people here think that that makes sense to give the API privilege, and how many of you think it doesn't make sense? So, how many of you think it does make sense for the API to grant privilege? No, but how many of you think it's a bad idea for the API? None of this elbow stuff. Okay, great. Thank you very much. Now, I've justified my presence. Justified my data model. Data model. Our data model has changed completely. Great. You don't even talk about files anymore. You talk about resources. What's a resource? It's something my application accesses and does stuff with. Well, does it exist on a disk? I don't know. It's a resource. Okay. Well. Yeah, the model is completely different now. We no longer care about the fine granularity of this file. I care about the World Wide Web, or I care about the telephony stack. These are resources. These are the things I want to control. This is a radical change from what operating systems have grown up with over the past 30 years. The old notions no longer apply. Linux security is based on multi security. Multics begat Unix, which begat Minix, which begat Linux. Just to give you an idea how long ago this was all done. Most operating systems most operating system security is based on a model which was created by two gentlemen named Dave Bell and Odgel. They were actually given the charter coming up with a mathematical description of the United States Department of Defense security policy for stamping documents. They used to have a big red rubber stamps to go and put the secret, top secret, no form. And they came back and they said, well, the good news is 90% of it is describable mathematically. 10% is not. So they threw away the 10%, wrote this mathematical model, talked about subjects, objects, and accesses, and they said, and here's the way your security should work. And everybody said, oh, finally, something we can actually put through the documents. So when we do a computer system, when we sell it to the government, they can look at it and say, yeah, you've got a security policy when you buy. And that was all documented in the United States NSA's Orange Book. They call it the Orange Book because it actually had a flaming orange cover. But it actually defined computer security as we know it up until about 5 years ago. So 2 questions here. Okay, how many of you have ever heard of Multics? Okay, great. How many of you have used Multics? Okay, it's like Unix except that it's got access control lists instead of mode base. Okay, how many of you were born in 1985? About a third.
I wasn't born in 1984.
Okay. So these notions, the notions that we've been working on are falling aside. And we have this great, wonderful tradition. We know how things used to be, and they're different now. Okay, so we have our old notions of access control. Again, Linux sees a responsible person out there. You're running programs, they're linking with libraries, they're doing DLLs, they're putting up things on the screen. Linux thinks it's your fault if you don't like what you see. It's your fault if that program does something you don't want it to do. Why? Because you chose to run that application. That's changing now. The new notion is that the application is a person, kind of like a corporation. Okay? It isn't an embodied person, but it has all the aspects of a person. It can be malicious, it can be jealous, it can do you wrong. You write country songs about it. I stop it. But we ascribe all the aspects of humans to programs, to applications. And you are not responsible anymore for what the application does. Just want to make sure I got everything. So, the kernel notions on access control. The kernel thinks it's got subjects, which are active processes. It's got objects, which are files out there. And it doesn't care about what the application is, what the library is. It just cares. It's got attributes on the program. It's got the attributes on the file. It's going to use those to make the decision. And beyond that, whether this file is an audio device, whether it's a disk device, whether it's in-memory files, it doesn't care. It's an object. I know how to deal with objects. Except, of course, for sockets and network packets, which he just lets in because at the time networking was very new. There was no notion of passing attributes about the sender. And so since there was no information about the sender except the address it came from, nobody was particularly worried about it because after all, there was this cable, it was about an 8 thick. It was bright yellow and it never left the building. So you knew everybody who was connected to that cable, so you may as well just accept the packets because it's not like there's going to be anything malicious on it at all. Because, like I said, it's all in the building. And the privilege model, the latest capabilities we have today, was designed to meet high assurance levels designed by these people who wrote the Orange Book back in 1985, who were a bunch of spooks at the National Security Agency sitting around in a room going, hey, what we really want is we want to break up privilege as much as we can. So you only have the privileges you need. It's like, well, the privileges that went into Linux are the privileges that the system calls actually used for the subjects to access the objects. And that works just fine when you're looking at that granularity. But once you start looking at things like, well, how many of you have ever actually looked at the Linux capability mechanism, by the way? Same guys. All right, well, it's broken up based on the kind of activity you're performing. Like if you're doing file system access, you're doing reads and writes, that's one set of capabilities. You're doing attribute changes like mode bits or ownership, that's another set of capabilities. But when you get into things like system administration, it all tends to get glommed into one. And that's because the POSIX group that was doing the work wasn't allowed to say anything about what was going on. And there were actually two factions. One faction said I want as few capabilities as possible, and the other faction said I want as many as possible. That faction, by the way, ended up with 330 capabilities on the system that they built. Anybody want to manage 330 capabilities? Well, Russell does. He's an SE Linux guy. He's got a lot more to worry about than that. All right, so modern notions of protection are very different, but a lot simpler. And they're saying that what you have is resources accessed by applications. So now I've got an application. It's this entity here. It does something, and it's got to go out and access resources. Now I have to find a list of my resources, and all I'm going to say is, can this item, can this program, this application access that resource? That's pretty simple. How much simpler can it be? Well, it's just fine if you actually implement that. The problem is that a resource is a very ill-defined term. And further, services, which aren't applications, access resources as well. So if you have a service that does things like listen to the internet, listen to the cell phone tower to see if there's a call coming in, it's going to access some of this data, some of these resources as well to make sure that things like you haven't turned off the ringer or turned on the ringer, whatever. So it's going to be accessing the resources as well. So that's kind of this. Well, is the service an application? Well, no, it's not. Well, but I downloaded it. Oh, so I downloaded a different application to perform that function. Yeah, well, okay, now that's a service. Yeah, it's not a service because that would be nobody's actually gotten to the point yet where they can actually differentiate clearly between those two particular functions. But I'll say more about that as we go. That and resources themselves can have components. For example, the telephony stack. Telephony, for those of you who are from the East Coast of the United States. And what that says is you've got processes that are running out there on your system that are actually doing things so that when the phone call comes in, it'll get recognized, and it'll check to see if it's a legitimate call coming in, or if it's a spoof call, or your SIM card actually has enough dollars left on it to pay for the incoming call. All these things are active components of your resource. So, in a way, you have a much simpler model. And in another way, you have a much more complicated model because your individual entities are themselves more complicated. Not necessarily in a bad way, but they are more complicated, more sophisticated, capable of more things. But then the good side is they're fingerprint. All right. So we now have modern notions. I haven't talked about access control now and security. They're very closely related. They're not the same thing. Just like security and cryptography are not the same thing. Which for a long time people believed, oh, my system's completely secure. I've got DES on it. All right. So what have we got here? I'm trying to remember what I need to say. The real reason for having the slides, by the way, is to remind you what you were supposed to say, not so that you can just read them. Okay, applications are people too. They are. That's the way we treat them. Like I said, they're sort of like corporations. Can we sue an application? We treat it like a person. We give all the attributes and aspects of a person. Why can't we sue it? Well, maybe you can sue the person who wrote it. I suppose, but what if it got compromised? When I put it on the Android store, what if somebody at Google snuck in, changed a few bits, and now it's malicious? Well, I didn't think of that way, so the person who did that obviously can't be caught, so should we sue the application? Good question. Of course, if we sue it, that means we have to pay it. So then we can tax it. So you're laughing. Okay. 10 years from now, think back and say, gee, I wonder if that was such a crazy idea. So resources can be partitioned. One of the fundamental aspects of an object is that it's a complete entity, and you access the object. With a resource, you can access part of the resource. So I can tell the application, yes, you can go look at the phone book, but you can only see entries that are marked as personal, not the ones that are marked as business, and you can only see the parts of the entry that I want you to see. And as an application, you're required to know which ones I want to see, because otherwise I'm going to get upset when my email address goes off to Barnes & Noble, and they start sending me things about how I should buy a Kindle every 20 minutes. So I covered that. Hey. Now I'll let the slides right. Now, we have modern approaches to operating systems, and this is actually true of systems in general. But what we see is that all development is rapid development. Has anybody signed up for a project where they're using the waterfall model recently? Okay, so everything is rapid development now. And you got multiple concurrent projects running independently. And then it all gets tossed together like a salad. They dump some vinegar on it and say, ta-da, it's all done. Oh dear, it doesn't work. Well, why doesn't it work? Well, because nobody put an architectural viewpoint onto it. And security is all about who can talk to whom these days. And so if these people are working in Bangalore, and these people are working in Melbourne, and these people are working in Osaka, and these people are working in Linköping, and they all dump their software together, pretty well guaranteed that if they don't have some key to make it all work together. So modern approaches to security are very interesting for somebody who's old like me, who's actually seen things go through security evaluations that took 5 years before we got the stamp. But we did get the stamp. All development is rapid development. And user space controls, well, no one has time, and it's all done in user space. All the controls are done in user space. Why? Nobody's got time to write code. I mean, great, do you know how long it takes to get code into Blue's kernel if somebody decides they don't like it? Either you have to outwit that person, or you have to wear them down with rationale reasons and promises that 3 distributions are going to be using it yesterday, and that these 4 major applications absolutely have to happen. It takes a while to get things into the kernel, even if they're good ideas. If they're bad ideas, it takes even longer, in most cases. Right, Russell? I tease Russell a lot. I am the official loyal opposition to SE Linux. Anyway, so all applications. So if you're actually going to do new operating system development, what that means is that all your applications are going to have to be new applications that are conforming to the user space controls you're putting in, because quite frankly, there is no standard for user space controls. Chrome OS has its way of doing things. Android has its way of doing things. I've got 2 operating systems from the same company. Different ways of doing things. iOS, which isn't technically a Linux system, but it's out there in the world, it's got their own way of doing things. Then we have HTML5 coming in, which has its own way of doing things, which of course is going to get implemented on top of Android and on top of Chrome OS and on top of Windows. And so you've got all these different application models for security coming in. And if you want to write any application, you're really writing a new application for each of these things, even if it does exactly the same thing. You know, Angry Birds for Windows, for Chrome OS, for that other Android. So long as it doesn't do anything that's going to require specific resources, you can have common code. But the reality is you've got a different version for each of those systems. And the modern approach breaks down in a number of cases. Now, I'm not trying to defend the old way of doing things. The old way of doing things had its problems too. Yes, it has many problems. But the modern approach breaks down because the rapid development only works half the time. One of the tenets of agile programming is that at the end of your sprint, everybody goes home and sleeps, comes back, and says, okay, what worked and what didn't? Because we're going to keep the stuff that worked and we're going to throw out the stuff that didn't. Unfortunately, no organization of larger than 20 people and no organization with experienced management is ever going to throw away something you wrote. Because we've invested in this. This is technology. It's our IP. We've got the patent process started and everything. We'll be throwing money away if we don't use this. So nobody ever throws it away, even though, according to your programming methodology, that's the thing you do half the time is you throw it away because it isn't really what you want. All right, so then you've got your legacy applications. These are the applications that you had before. Now I want to have this legacy application run on this brand new OS. Well, it doesn't conform to the user space controls because I wrote them for the previous operating system's user space controls. Well, now what do I do? Well, I retrofit, okay? And of course, they're native applications. These are my personal favorites. So you put together this system with user space controls, everything's fine, and then somebody comes along and says, but if I can't make seek system calls directly onto the my game will be slow, and the users won't have the experience that they want, and they're going to have to use that left thumb too many times, and they're going to die. So no, it's got to be native apps. I need native application support, even in cases where you actually see an implementation actually run through the course there. It turns out not to be a problem. People are still going to demand native support. So we need a different approach. And the old approach clearly isn't going to work in an environment where rapid development is what you have to do because that's what people are going to do. The new modern approach isn't going to be sustainable if you've got more than one system involved. So what are you going to do for your approach? First off, you have to admit that rapid development is okay. Really, there is nothing wrong with rapid development that throwing away half the results won't cure. Again, convincing your boss that it's good that he's throwing away the code you just spent 3 weeks on, and that it's not going to be on your performance review that, gee, half the code he wrote we threw away. They've accepted the development model. They need to live with it and actually accept the development model as opposed to the glorious view of the development model, which is that you work like a dog for 3 weeks, and then you work for a dog for another 3 weeks, and then you work like a dog for another 3 weeks. And whatever security model you're going to put into your applications, it's actually going to get used. That means legacy applications got to be retrofit to use it, sorry. And native applications, they're fine so long as they conform to the security model. That's kind of brutal. A lot of times people do things like they say, hey, we're going to use this library. What's this library do? Oh, it does a shared memory transport between applications to make them faster. Well, and what's the security implication there? Oh, well, they can share any data they want. And what's the security implication there? Well, they can share any data they want. Oh, what can we do about that? Oh, well, ignore security. Oh, okay, yeah, we'll ship it then. So long as you're admitting it, that's fine. And so what we need to do is put security underneath where possible. What does that mean? Well, that brings us back to our operating system kernel again, which is underneath everything. Or, if you prefer, if you want to have browser-based security, that's fine. Everything's got to run on the browser. If you want to have a pure HTML5 environment, you can do that, and that'll work, so long as your security is done underneath. If you want to have an Android-like environment where everything is done from client server, that'll work too, but you got to do everything there. Well, I just ranted for 45 minutes. That felt really good. I've talked about the things that I like about security these days, and I've talked about the things I don't like. I think we have a lot of potential, a lot of things we can do. Every now and then I get tempted to say that it's hopeless, we're all going to die, nothing will ever be secure. And other times I say, well, all it's going to take is a little bit of cooperation from the developers. And then I think about it, and I usually back to my first stance. But we have a lot of potential now. We have a lot of things going on there. 5 years from now, you won't recognize computer security if you know what it's like today, because you're in the media transition. And if I can just put one message out to you today, That's it. It's all changing. It's one of the most exciting times in computer security that we've ever had. And I'm looking forward to working with you. So now I'm going to take questions. Somebody has got to have a question. Okay, thank you. I was going to make you, I was going to stand here until somebody asks something. There you go now.
So do you see application developers embracing this? Do they, or what's motivating them to get involved to actually to make things better?
Okay, so what's motivating application developers to get involved in security? Absolutely nothing. There's nothing application developers want to hear less than, you know, that we have a security issue with this. Because that's not 50. The common perception is that security is not my job. You have put the security mechanism in place so that I don't have to worry about security. Now you're telling me that I have to worry about security. Well, why don't you have this big security mechanism with resources that I need to declare I need to talk to, and I need to declare if I'm going to use files, and I need to declare if I'm going to use the network, and I need to declare all these things. And I have to write a manifest file that's 3 times the size of my application. And now you're telling me I have to worry about security. What gives? I'm going to have to actually know what's in my manifest? Well, why should I have to know what's in my manifest? That's not my program. My program does this. All it does is this little thing. I mean, all it does is take passwords and mail them to the mothership. That's it. That's all it does. Why do I need all this manifest stuff? Application developers hate security. They always will hate security. They have good reason to hate security. They hate security more than they hate performance issues. So I don't know any way around that, because security really is about containing and controlling the behavior of applications. And application writers get paid to make applications do. So next question. I hope that answered it. I don't have a soapbox. Actually, I do. Look, it's got a lock on it. Good. Security. Okay, so next question. Okay, I can get by with this. It's great. Oh, okay, yes. Okay, Mr. Front Row. Who else put the good hecklers in the front row?
Okay, so as a security consultant, if I can ask the client to do one thing, as a developing an application or whatever, what would it be?
So as a security consultant, and your client is developing an application, you want to ask them to do one thing. Okay? Design your application. Yeah, I know. Okay, everybody's jaw goes. No, seriously, design it. Decide what it's going to do, decide what it's not going to do. Because you as a security consultant can then look at the design and say, well, you can say 2 things. One is, with this design, you're going to have this set of security problems. And when they've implemented it, you can then look at the implementation and say, this implementation does or doesn't match the design, and here's why. And having not matched the design, you're opening yourself up to these issues that we addressed when we reviewed the design. So that's the one thing you can ask them, design your application. I realize, again, the rapid methodology has its advantages. The big disadvantage is that you can't tell whether what you got is good or not, because you don't know what you're heading for. Unless you actually use, if you actually use the actual methodology and say, here's what it does. Do you like this? Yes. Okay, let's write down why we like this, so that we'll remember. So at the end of the next sprint, we don't just say, oh, we don't like this, but what don't we like? Well, we don't like these things we liked last time. Oh, well, why didn't we like them last time? Not if you follow. So the whole notion here, get somebody to put down what it is you want to do. Because I've actually heard security defined as a program does what it's supposed to do and doesn't do anything else. And if you don't know what it's supposed to do, you can't make that determination. Okay, next. Okay, well, thank you. It's break time.